Hi, I'm Mike Stanzik and this is Digital Electronics Classroom. In today's video we're going to be looking at the ones and twos complement procedures. We're not going to look into the reasoning behind doing these procedures or exactly how they work. We're just going to look at the procedures themselves today in these videos. So let's get started. So we're looking at the ones and twos complement. And we'll talk about two constraints here. One is that we must use, or two, I guess, bullet points, not constraints exactly. One's a constraint. We must use fixed length numbers. And then the second bullet point is that this process is useful in subtraction in computer systems. And so that's the reasoning behind why we do it, but there's more to it than just that. But for now, that's good enough. Okay. So the ones complement is, I'm just going to abbreviate this as ones from this point forward instead of writing complement. So for ones, we're going to subtract our number from the largest possible number. Okay, so let's create our number. And I'm just going to make this up. So we're going to go 0, 1, 1, 0, 1, 1, 0, 0, and this is our base 2 number. Okay, so that's our binary number. We just created that. That's ours. We made. Now I'm going to look at the max number. So what's the max number that I could have for 8 bits? Well, the max number is going to be all ones. So we have the max number, we have our number, and so the ones complement is going to be equal to the max number subtracting our number. So we just one by one do this. So 1 minus 0 is 1, 1 minus 0 is 1, 1 minus 1 is 0, 0, 1, 0, 0, 1. And so this is our ones complement right there, the answer there. Now, one thing that you might see that's really cool with this process is that we'll never have to borrow from the next place in line when we do the subtraction, because we're starting with each digit in our number, our max number, being the largest digit possible. And so we're subtracting anything that's going to give us at the minimum 0. We'll never have it where we have to take from the next one. So that makes this operation really easy to do. So it's a simple, pretty simple procedure. So that's our ones complement. Okay, and so our twos complement is the ones complement plus 1. So we're going to add 1 to the ones complement. So for twos, we just add 1 to the ones complement here. Okay. And in this case, we are going to have to, let me just kind of circle this one so we know that's an answer there. We are going to have to carry in this case. So we do carry when we add the 1. So we have 1 plus 1 is a 2, so I have to carry the 1 to the next. Anytime we're adding both ones, we'll have to carry a 1. So I carry a 1 up here, 1 plus 1 is going to give me 2 as well. Carry the 1 up here, and then that just comes down to the bottom. And then from the rest of these, we're just bringing them straight down. So our twos complement looks like that. 1, 0, 0, 1, 0, 1, 0, 0, which is just our ones complement plus 1. And that is the process, that is it. So now you know how to perform a ones complement and a twos complement by doing that operation. One more thing I want to point out, which makes this even easier for the ones complement, is if you compare these two numbers, our original number and the ones complement, you'll notice that to get from one to the next, and you can go both ways here, all you have to do is toggle or flip the bits. So toggle or flip the bits. So procedurally, on the ones complement, we can subtract our number from the largest possible number like that, or we can just remember to flip the bits, right? It's kind of fun to say, flip the bits. Okay, all right, so that's it. Thanks for watching this video. Thanks for your time. We really appreciate you here at Digital Electronics Classroom. When I say we, I mean me, as I make these videos. Please like and subscribe. Really appreciate that as well. Help support me, make me feel good like you're watching and you like my videos. Yeah, so see you next time for more digital electronics videos. Have a great day.